force is a vector quantity. So we are going to again use another Ratchet rule in this section for finding the direction of the magnetic force acting on a charge particle. Right hand rule in section 3 is completely different than right hand rule section 2. In section 2, there were only two quantities. One of them is the electric current, the other one is magnetic field. Two quantities, and you curl your hand like this. So you never do it like this. Curl. So we learned two right-hand rule for this. For straight wire, thumb is electric current direction, curled forefinger is magnetic field direction around the wire. It was the first one. It was for straight wire, but for circular currents, loops and coils and solenoid, forefinger is the electric current direction, thumb is the direction of the magnetic field. At the same time, which side is the end pole of this device. And don't forget, only two quantities we have in section 2. But now in section 3, we will have three quantities. And we are going to open the hands like this. We will not curl it. Straight, flat. So, three quantities we are going to show in here. Magnetic field, B. Direction of the velocity, V. And direction of the magnetic force, F. So, in this section, only the right-hand rule, this we don't have any other. So we are going to use this one. You are going to open your hand, so flat. So your thumb must be perpendicular to your forefingers, okay? Now, what represents in here? Direction of the magnetic force on a moving charge. Of course, the charge must be moving, otherwise there will be no magnetic force. You know that. Can be found by right-hand rule. Forefingers point in the direction of the magnetic field of the lines. In which direction magnetic field is, your forefinger, 1, 2, 3, 4, will represent the magnetic field direction, B. This is B. Thumb will show now direction of the velocity. In which direction the particle is moving, direction of velocity. And palm will show you, palm, the magnetic force acting on the charge. Yani, as charge is moving like this in a magnetic field upward to the sky, when charge is moving like this, there will be a force acting on the charge in direction of the path. So palm will show the force acting on the charge. But it is for positive charge, because there are two types of charges. For positive charge, palm will show the force acting on the charge. But for negative, what do you expect it to be? Opposite. In electric field, also it was like this. Positive charge, electric force, in the same direction of the electric field. For negative charge, in the opposite direction of the electric field. Remember, I explained this. Here's also opposite. Palm will show you direction of the magnetic force acting on positive charge, and proton. Opposite of your palm, here, this side, will show you that this pen now shows the magnetic force acting on negative charge, which is electron. Okay? So, this is the force, direction of the force acting on a positive charge. This is direction of the force acting on a negative charge. They are opposite. Yani here is positive, here is negative. But in here, be careful. Magnetic force, this pen, perpendicular to magnetic field. Look at that. What is the angle between my forefingers and the pen? 90. Always. Magnetic force, this or that, doesn't matter. Always perpendicular to magnetic field vector. So if they ask me this question to you, what is the angle between magnetic force and magnetic field? How much? 90 degrees. Not only this, look at the angle between my thumb and pen. What is this angle? Again, 90. So magnetic force is perpendicular to both magnetic field and velocity. The angle between magnetic field and magnetic force and magnetic field is 90 degrees. Angle between magnetic force and velocity, again, 90 degrees. Okay? And angle between V and B can change. It's up to you. If you move the particle perpendicular, maximum magnetic force acts. If 30 degrees, half of that. If parallel, 0. So, this thumb can make different angle with magnetic field. It's possible. I think this is all about the right-hand rule in section 3. Now we are going to apply this to some problems. Okay, this is one of the chapter question, to question number 27. Find the direction of the magnetic force on a proton. It's a positive charge. So you should check first. Is it positive or negative? So proton is a positively charged particle. So you are going to use for magnetic force the palm. Palm will show you direction of the magnetic force acting on a proton. So moving through each magnetic field in the 4 figures below, A, B, C, D. By the time this is the ministry exam question of the last year. They asked this exactly the same. So now let's do the first one. I'm going to first show on the board, because my board is in vertical. Then I'm going to show on the page, which your page is in horizontal, okay? So on the board, I'm going to show you, follow me. Always start by magnetic field, showing by magnetic field. Now these dots, these crosses are representing magnetic field lines. Is it into the page, into the board? Yes. Just take your forefinger and show in the direction of magnetic field. Is it showing the direction of magnetic field now? Okay. Second step. Change the direction of your thumb in the direction of V. My thumb is now showing it to the left, but it must up to the page. So I have to change it in the direction of V without changing direction of V. Yeah, you shouldn't change direction of V. Okay, now look at my palm. My palm points in which direction? To the left or to the right?
To the left.
To the left. So it's going to be to the left. The force acting on the proton, moving this magnetic field, is going to be to the left. I'm doing again, follow. First open your hand just like this. First start showing the direction of the magnetic field, forefinger. Forefinger points, which is crossing into the board, show it into the board, direct, first do it. After that, hold your thumb, change its direction in the direction of V. Yes. Then look at the direction of your palm, use your pen, put your pen in your palm. It's showing which direction? To the left. Left is the direction of the magnetic force acting on the particle. Now I will do it on the page, according to your page, okay? This is your page, huh? Magnetic field is into the page. So your forefinger must show into the page, just like this. After that, change your thumb in the direction of V. V is up to the plane of the page. Change it to the up to the plane of the page, like this. My thumb is showing now up to the plane of the page. Look at my palm. It's pointing to the left. It's pointing to the left. The magnetic force acting on the charge is to the left. So this was the ministry exam question of last year. In which of the following direction of the magnetic force is to the left? So we found it. Correct answer was A. Let's find for B, C, and D. For B, what we have to do? First, forefinger magnetic field. You will start with that. Magnetic field is to the right. So I just showed my forefinger to the right. You see that? Then, thumb, change direction of the thumb in the direction of V. My thumb is pointing now wrong. I had to change it up to the board. Up to the board. I changed it. Did I do correct? Okay, look at my palm now. Into the board. It's showing into the board. So, according to you, it's going to be into the page. Now, let's do it for your page. First, magnetic field must go to the right, correct? So, do it to the right. I did it. Okay, is it to the right now? After that, thumb. Change your thumb direction up to the page. V is up to the page. Now, palm is pointing into the page. Your palm is pointing into the page. It's going to be represented by a cross or dot? Into the page is going to be cross. So magnetic force is into the page, which is going to be cross. So let's show it like this. V This is magnetic force, which is into the page. Now let's apply C. First of all, I will do on the board. Magnetic field now, down to the board, is it? So my forefinger must show down to the board, correct? And V must show to the left. And my thumb is showing to the left. Look at my palm. Palm, out of the board. It's out of the board, is it? It's going to be that. It's going to be that. Yeah, in here, it's going to be that. Magnetic force acting on proton is going to be now. F magnetic is going to be that. Let's see according to your page. Forefinger is down to the page. Is it down to the page now? Forefinger? Yes. Thumb must show to the left. Is it showing to the left?
Yes.
Yes. So look at my palm. It's pointing out of the page. I don't have another pen. I would like to show the pen, but you can use your pen. You can put on your desk, but I cannot put it on the desk. So pen will show, if you put your pen on your palm, it will show out of the page. And last one. Magnetic field is out of the boards. Yani, I'm going to show it like this, out of the board. But I have to show V to the left. Now my hand is showing out of the board and my thumb is to the left. Look at my palm. It is up to the board. Up to the board. So it's going to be like this. If you put a proton in here, in this direction it's moving, magnetic force is going to be up to the board. Let's do it according to your page. According to your page. So it's going to be like this. This is your page. Magnetic field is out of the page. Forefinger must show out of the page. Now my forefinger is showing out of the page. Is it out of the page? Yes, you see that. Thumb must show to the left. My thumb is showing to your, yeah, like this. Use your page. Ha. Ya da take your page up in here. Study with your page. Pagesiz yapma. Yani öyle olmaz. To hold your page like this. Okay. So magnetic field is out of the page. Correct. So for V is to the left. Correct. Look at my palm. My palm is in which direction? Up to the page. It's going to the up to the page. Look at that. My palm is up to the page, right here, to the top. Palm is pointing to the top. Correct. So it's going to be up to the page. All right, this is one of the good examples. There are very different directions, and we need all possible questions which can be asked. And in last year's ministry exam question, A is asked. They asked in which of the following the magnetic force is to the left of the page. So you see that F magnetic is to the left of the page. And you go home, open ministry exam questions, do it again. It's going to be a revision for you. Okay. Now we will solve a problem. This problem will include both magnitude and also direction of the magnetic force. A uniform 1.5 Tesla magnetic field. You know what this is? B. B is 1.5 Tesla magnetic field. Points to the node. So, again we are going to use third set. North, south, east, west. Upward to the sky, downward to the ground. Okay. Magnetic field is 1.5 Tesla to the north. Let's draw it. So magnetic field is 1.5 Tesla to the north. Did I draw the magnetic field vector to the north? Is this correct? Is this drawing correct? Yes. So it's to the north. If electron moves, this time electron, so it is negative charge, moves vertically downward towards the ground. V is downward now. The electron is moving just like this, downward to the ground, to the earth. So how we are going to represent it? By dot or cross? Downward to the ground is going to be cross. We are going to represent it by cross. Now by the time charge of electron and proton are equal, 1.6 times 10 to the power negative 19. As I said, it will be given, I forgot to write, but it will be given in the questions. 1.6 times 10 to the power of negative 19 coulomb. Both electron and proton has equal magnitude of the charge. One of them is positive, the other one is negative, but we don't write negative in calculations, okay? So Q is 1.6 times 10 to the power negative 19 coulomb. And this electron is moving vertical downward. I'm going to represent by cross. V is going to be cross. 2.5 times 10 to the power 7 meters per second, but V is going to be represented by cross, which shows you in downward to the ground on your page. All right. What force, magnitude, and direction, we will find both of them, will act on the proton? So, tell me, what is angle between B and V? 90. Because B is in horizontal, but V is in a vertical. And so what is angle between a horizontal and vertical line? 90 degree. So angle between B and V, 90 degree. Yani theta is 90 degrees. Okay, if 90, maximum magnetic force acts on the charge. So let's write. What is the equation for maximum magnetic force? QBV. You don't need to use angle because sine 90 is 1. Q is given 1.6 times 10 to the power of negative 19. B is given 1.5 Tesla multiplied by V is given 2.5 times 10 to the power of 7. Multiply them all. How much is the answer? 6 times 10 to the power of negative 12 meters. Okay. First calculate the magnitude. This is the easiest part. First calculate the magnitude. This is the easiest part, and we did. Now direction. I am going to answer, of course, according to your page. Why? Because your page is horizontal, my board is vertical. Now I will do according to your page. Magnetic field is to the north. North is to the top of your page. Now follow. North is to the top of your page. You are going to show your 4 fingers to the top. And V is downward to the ground. Your thumb must show downward to the ground. What is it, positive or negative? Electrons positive or negative? Negative. So opposite of your palm. Look at my opposite of my palm. It shows? West. Which direction is it? West. West. It is west. Left yoke. We don't have left in here. We have west. West. This magnetic force is going to be to the west because my opposite of my palm points to the west. This is? West. West. This is east. You have to draw them, okay? So, again I am doing it. Now I don't hold horizontally to make you see it. North, south, east, west. First magnetic field, in which direction? To the north. Show your forefinger to the north. Then V. Now V is wrong. My thumb is pointing west. But I have to reach downward to the ground, which is into the page, according to your page. Then look at my palm. Palm is to the east. Opposite of palm is to the west. So the magnetic force on the electron is to the west. So how can we give the answer? Answer is going to be like this. In choices, they will give like this. For example, say the choice A. Force is 6 times 10 to the power of negative 12 Newton. They are going to put a comma in here. In which direction? You will write in here, west. So this is how we are going to answer these questions in ministry, okay? Now one more exercise, one more problem. This one, again electron. In the sample problem, practice problems, electrons are given. So again, it is negative. So the magnetic force is opposite of your palm. If an electron beam, what is electron beam? If billions of electrons are moving one after another, it's called a beam. There are flow of electrons. Many electrons, several electrons are moving in one direction. It's called a beam. Yeah, and inside this beam, one electron. We are talking about just single electron. Experience a downward force. This time, force is given downward. Okay. Force is given as 2 times 10 to the power of negative 14 Newton while traveling in a magnetic field. So B is given to the west. Which set we are going to use? Again, we will use third set. East, west, north, south. Downward to the ground, upward to the sky. Okay. What is direction and the magnetic velocity? This time velocity is the question. And you will look for thumb. But by the time it's electron, electron has a charge exactly the same as the proton, 1.6 times 10 to the power negative 8. As I said, it will be given in the problem. You don't worry about this. And now, next one. Force is downward to the ground. Downward to the ground is represented by dot or cross? Cross. So, force is going to be cross now. Force is going to be cross. I draw it and then you also draw the same thing on your page. F magnetic is cross. Yani downward to the ground. Traveling in a magnetic field, but magnetic field is to the west. Magnetic field is to the west. So I am going to draw B to the west, and it is equal to 8.3 times 10 to the power negative 2 Tesla. So this is B to the west. What is the direction of the magnet or the velocity? First calculate magnitude. Always start with magnitude. It's the easiest part. Okay. What is the magnitude of the velocity? Find it. F, maximum magnetic force acting on the charge is QVB. Okay. So we know what F is. It's given. Is it given? Yes. Q is given. Yes. B is given. Yes. What is unknown? V. So V is unknown. So simplify Q and B. Divide by QV. Divide by QB. Simplify Q and B. So V is left. V is equal to F maximum divided by QB. Okay, I know how much is F maximum. Yes, it's given. 2 times 10 to the power negative 14. 2 times 10 to the power negative 14 Newton. Divided by Q is 1.6 times 10 to the power of negative 19 times, how much is B? 8.3 times 10 to the power of negative 2. Because writing is the denominator, you should take it into brackets. One bracket before and one bracket after. That's all. Not more than this. Okay? Result is going to be how much is B? 10 to the power of 6 meters per second. Okay, this is magnitude. Now, direction. Ready? North, south, according to your page. East, west. Downward to the ground, upward to the sky. First start with magnetic field, because it's given. Magnetic field is in which direction? To the west, I think, huh? To the west. I drew right there. So, this time I'm going to change direction now. I had to make it my job easier, of course, okay? So my forefinger is down west. Yes. My forefinger is down showing west. First step is okay. Now second step. Force. Opposite of your palm must be downward, but now mine is showing upward. This is wrong. Look at my opposite of your palm. It's showing upward. It must show downward. So I will twist my wrist. Now it's downward, is it? So my opposite of your palm, my palm is showing downward. Look at B, to the west, everything is okay. Look at direction of thumb. It is north. So we must be to the north. So answer is north. So if we write it, draw it, it's going to be like this. North. B is going to be to the north. And in the choices they are going to add in here. Yes, V is going to be in 1.5 times 10 to the power of 6 meters per second and comma. North. You are going to write